Hello viewers, welcome to another math question by Martin Tutorials. I do apologize for the delay, but I was sick. I had a small operation. I might need another small operation, but hopefully we can have some more fun with mathematics. This is today's question. I love questions which might happen in real life. It gives meaning to mathematics. We are given 80 feet squared. That's the area of material. We're using it to create a box with a square base and an open top. What are the dimensions to maximize its volume? So there's a nice diagram, and we've got like a box. The bottom is a square. The height might be different. Given that the bottom is a square and a certain height and 80 feet squared of material, how do we maximize the volume of this shape? And a quick reminder, I have a brand new YouTube. This is our Martin Tutorials, Variety and Fun Math is from before, and Martin Talks, where I give my opinion on issues. I now have 3 YouTubes. And now to tackle this question. What I do is I let S be the length of the side of the box and H be the height. There's my S, and there's S, and that's H. H is the height. Okay? And the total material we need and the surface area of the box. The surface area is the area of the base and the 4 sides. The base is S times S, and the area of each side is S times H. So we've got S squared, the bottom, and 4 lots of SH, because there are 4 sides, equals 80, because we have 80 feet squared of material. The volume of the box, of a rectangular box, it's length times breadth times height. Well, the length and breadth is the same. We called it S, so it's S times H, which is S squared H. The volume is S squared H. As this is a calculus question, and volume is what you want to maximize, that's what we want to find the derivative. But as you can see, there are too many variables. We need to get rid of an S or an H. So what I'm going to do, I'm going to take this equation for the surface area and use that to isolate S to substitute into this equation. And always when I look for this equation to substitute in, I always think of what are my limitations. The question is how do we maximize volume? Why not just make it 1,000,000 feet by 1,000,000 feet? Well, we limited to the amount of material we have. We've got 80 square feet of material, and I usually use that as equation to substitute in. So what I've got to do is take this equation and isolate S. I'll call this equation 1 and call that equation 2. So we're going to use equation 2, and we're going to eliminate a variable in 2. So here's our equation, and we want to isolate that H. We bring that S squared to the other side, and we divide each side by 4S, and now we've got H equals 80 minus S squared divided by 4S. One thing, sometimes I prefer to choose the advantage of using an S, it can mean side. The problem is it can look like a number 5. Usually I avoid letters which we can confuse with a number, but it's not serious. We know it's an S. So there's our equation. V equals S squared H, and we're going to substitute in. We replace this H with 80 minus S squared over 4S, because we solved for H in this equation. And what I'm going to do now, this is an equation for V with only S's. I'm going to simplify it for purposes of doing the derivative. Now, there's no rule saying we have to simplify. Whatever you're comfortable with, someone can just go ahead and do the derivative here. So one thing I do notice, we can eliminate an S. There's an S in the numerator and denominator. So that S just becomes S, and that just becomes a 4. And there I wrote the S, and I multiplied the S in. We've got 80S minus S cubed. And for purposes of doing the derivative, instead of writing the 4 underneath, I wrote 1 over 4 at the beginning. And as always, when there's different ways of doing things, always do it the way your instructor tells you. Of course, many people are watching this, so I cannot do it the way your instructor tells you. Let's say you're in secondary school. So, but I happen to like to write it like that. And this is something funny. I made a mistake. Can anyone tell me? There's the equation, there's the derivative. The derivative I did beautifully. A constant remains a constant. Can anyone see what my mistake was? I wrote V and V. It's V prime, or dV over ds. There we go. There's a little, I shouldn't sit. That's the prime side. This is not V, this is V prime, this is derivative. 80s becomes 80, and the 3 comes down, and we reduce the numerator by 1, so it's 80 minus 3s squared. That's what we want to set to 0. I can remove that quarter altogether, because when the brackets equal 0 is when the quarter times that bracket equals 0. So I can just take 80 minus 3s squared, set it equal to 0, and I bring that 3s squared to the other side. Divide each side by 3. What you do to one side, you do to the other. S squared equals 80 divided by 3. And therefore, S is the square root of 80 over 3. I rooted both sides in an equal sign. And the question is, how do we write the answer? Do we use a root sign? Do we write decimals? I always look at how the question's asked. In this question, they didn't make any specific claims of how to write it. So there's many correct ways. One way is to just plug in your calculator. 80 divided by 3 square root, and to 2 decimal points is 5.16. Okay. These are other ways of writing it. I could write that as 16 times 5 over 3, and the root of 16 is 4. So I bring the 4 out the root sign. That's all correct. So that's what S equals. And I'm not saying this is the best way. That's the way I did it. You do, if your instructor told you another way, you do it your instructor's way. This question didn't make any specifications, so I wrote it as 5.16. Now we know from before, higher up, there's an equation for H. I can plug this in to solve for H. So H is 80 minus S squared over 4S. And we know we said S is the root of 80 over 3. So S squared is 80 over 3. It's the root of 80 over 3 squared. 4 times S is 4 times the root of 80 over 3. I could have put in 5.16 as well. Maybe this is more accurate because this is closer to the original number, which will mean my answer will be more accurate. And if I solve that, I plug this into the calculator. I'll get, well, to 3 decimal points is 2.582 feet. Or in 2 decimal points is 2.58 feet. We already know volume is S squared H. S squared is 80 over 3. H is 2.582. We solve that, we get 68.85 feet cubed, because we are dealing with volume, not a length. Not the length of the height or the length of a side. That's why that's an important little 3. I could have made that T more clear for the word foot, FT. And so there's our answer. To maximize the volume, the box should have a side of length 5.16 feet, height of 2.58 feet, and a volume of 68.85 feet cubed. That's everything to 2 decimal points. And there's the diagram where I put that 5.16 is each of the 4 sides. The height 2.58, each of the vertical lines are 2.58, and the maximum volume, which is side this length, the bottom length times height, that's S squared H, which is volume, is 68.85 feet cubed. Thank you for watching.